Hello friends, welcome back to the class. In this video, we are going to discuss about cholinergic receptors. So, what are the cholinergic receptors? Right here, the cholinergic receptors are nothing but the neurons which are going to release acetylcholine, that is called cholinergic receptors. Otherwise, yes, the receptors which are activated by acetylcholine are called cholinergic receptors. Here, the cholinergic system, it is an important for parasympathetic nervous system. Important for parasympathetic nervous system. So this is supplies nerve to smooth muscles and cardiac muscles. It is going to supply the nerves to smooth muscles and cardiac muscles. Here, this is the responsible, acetylcholine is responsible for stimulation contraction of smooth muscles. That means, what is that? So, stimulating and contracting the smooth muscles. So, in gastrointestinal tract, urinary tract, and also increasing the heart rate and lowering the BP. So therefore, these effects are exactly opposite to adrenergic receptors. These are exactly opposite to adrenergic receptors. So friends, this is about right. Yes, this is about the introduction of cholinergic receptors. So let's see the biosynthesis of cholinergic receptors. Biosynthesis of cholinergic receptors. Right here, let's start with this is the molecule serine. Okay, so the serine by using an enzyme serine decarboxylase. The enzyme name is serine decarboxylase. There is only decarboxylase means it is going to remove carbon dioxide from carboxylic acid. Yes, so now it is converted into ethanolamine. The compound name is ethanolamine. This ethanolamine react with, so you know that in choline on nitrogen there is 3 methyl groups. So therefore we are going to add methyl groups on this nitrogen. For that we are using choline N-methyl transferase. So to do this reaction, so in biosynthesis we always use SAM, S-adenosyl methionine, SAM. Yes, adenosyl methionine. So on this nitrogen we are going to introduce 3 methyl groups. So this is the compound we call as choline. So but what is our product, what is our final product? Acetylcholine. Therefore we want to do acylation. In biochemical reaction for acylation we always use acetyl CoA. So here acetyl CoA. So to do this reaction we need an enzyme. The enzyme name is acetylcholine transferase. So now the acylation takes place at this position. The product is acetylcholine. So friends, this is the biosynthesis of acetylcholine. Now inactivation of cholinergic receptors. So when acetylcholine is biosynthesized, then it is stored in storage vessels. Once acetylcholine biosynthesized, so it is stored in storage vessel. So friends, when it is released, that means so acetylcholine is released, this will interact with cholinergic receptors. Now this cholinergic receptor converts acetylcholine into acetic acid plus choline. So the reverse reaction of biosynthesis of choline. Okay, right friends. Here the classification of cholinergic receptors. Cholinergic receptors are classified into two types. The first one, yes, muscarinic receptors. muscarinic receptors. Here these receptors present in smooth and cardiac muscles. Second one, nicotinic receptors, muscarinic receptors, nicotinic receptors. So these are present in skeletal muscles and nerve to nerve synapses. So friends, cholinergic receptors are classified into two types: muscarinic receptors, nicotinic receptors. Now let's start muscarinic receptors. Here the muscarine act as cholinergic agonist. Let's see the structure of muscarine. So to write the structure, yes, here it is a 5-membered ring. So friends, muscarine is a 5-membered ring. Okay, so this is going to have oxygen, that means furan ring is present. So now this furan, tetrahydrofuran, going to have methyl group at the top position, and here at the top position we are going to have, yes, yes, N. So this nitrogen attached to 3 methyl groups, so that means quaternary salt. Yes, quaternary salt. When nitrogen has 4 bonds, obviously it has a positive charge, and here this position we had a OH group. So friends, this is the structure of muscarine. Therefore friends, this is the structure of muscarine. So now what is the use of the muscarine? So these receptors mediate cholinergic responses. It is going to mediate cholinergic responses. What kind of responses? Cardiac inhibition, peripheral vasodilation, that means lowering the BP, and also it is going to increase flow of secretory glands, increasing flow of secretory glands. So furtherly, these receptors are classified into 5 types. Those are M1, M2, M3, M4 and M5. So friends, this is about muscarinic receptors. So the next topic about cholinergic agonist drugs. Cholinergic agonist drugs. So what are the cholinergic agonist drugs? When there is a deficiency of acetylcholine, we need to activate cholinergic receptors. Therefore we have to give the medicine from the outside. So those medicine activate cholinergic receptors, that is called cholinergic agonist drugs. So now, yes, examples are acetylcholine, carbachol, bethanchol are there. So these are the examples. So the first one, so very well known compound, acetylcholine. So what is the structure of acetylcholine? So first you have to draw the choline. Yes, choline means it is a quaternary. So this is ethanol amine. This ethanol amine, if it has 3 methyl groups and on the nitrogen 4 bonds are present, therefore it has a positive charge. This is called choline. So acetylcholine means, so this is, sorry, acetylcholine means this is going to have acetyl group. So the group is acetyl group. So this is the structure of acetylcholine. So the structure of acetylcholine is this. So let's see the synthesis. To do the synthesis, I am starting the synthesis with epoxide, react with trimethylamine. So trimethylamine going to have lone pair of electrons. These lone pair of electrons attack at epoxide. It is a nucleophile. So epoxide can easily undergo ring opening reaction. These electrons attack at this position. Now this bond opened onto the oxygen. So the product is obtained by opening of reaction. So due to shifting of this bond onto the oxygen, oxygen has a negative charge. So it is on acidic hydrolysis. This O minus takes the proton, convert into OH. So now the difference is only acetyl group. For that I am going to use acetic anhydride. This acetic anhydride going to react with OH group, convert into O-acetyl group. So friends, this is the compound acetylcholine. So the next concept is muscarinic antagonist drugs. Muscarinic antagonist drugs. The first one, atropine. So friends, let's see the structure of atropine. For that, you have to draw a cyclohexane chain conformation first. So this as a nitrogen at this position, this nitrogen going to have CH3 group, and here at this position, so you see, so here at this position a bond is present and another bond is there. So this is connected to that here. Okay, so now here at axial position, so ester is there. So ester, so ester means OC double bond O, and here yes, so this is going to have pH group. So this is a phenylacetic acid only, so the ester of phenylacetic acid, but at a benzylic position it is going to have, yes, sorry, it is going to have CH2OH. So this complete molecule is present at axial position of this chain conformation. At equatorial position we have the at equatorial position we have the hydrogen. So this is the structure of atropine. So the structure of atropine is this one. So what are the medicinal uses of atropine? So medicinal use. So here friends, this is a natural product. It is obtained from Atropa belladonna. Natural product obtained from the plant Atropa belladonna. So why we are using this compound? So it is going to decrease gastrointestinal mobility. So that means our stomach mobility. So it is going to decrease gastrointestinal mobility. So here it is used in the treatment of the Parkinson disease, also used in treatment of Parkinson disease, and also to counteract anti-cholinesterase poisoning. When choline undergoes some reactions that is going to make poison, so in that case it is going to stop that reaction. So these are the uses. Here friends, how it is working? So the nitrogen on, so this is the nitrogen, this nitrogen is going to be protonated. That means it is converting to, it is taking, this nitrogen is going to take proton. So now it is going to have positive charge. So this nitrogen is protonated and thereby binds with cholinergic receptors. Bind with cholinergic receptors. So friends, this is about atropine. So next concept is nicotinic antagonist drugs. Nicotinic antagonist drugs. So these are comes under ganglionic blocking agents. Ganglionic blocking agents. The first one is nicotine only. Where is the nicotine present? Nicotine present in, we already know that, tobacco. Okay, let's see the structure of nicotine. To write the structure of nicotine, so nicotine is a pyridine derivative. So first we are taking a pyridine. So this pyridine, okay, going to attach, yes, going to attach by a right pyrrolidine ring. Which ring? Pyrrolidine. That means 5-membered ring. So this 5-membered ring going to have yes NCH3. So this is the structure of nicotine. Friends, let's see the structure of nicotine. Yes, this is the structure of nicotine. So here it is going to binds with ganglionic nerves, going to binds with binding site of ganglionic nerves. Okay, so next neuromuscular blocking agents. Neuromuscular blocking agents. So generally friends, these are used when the doctors are doing the surgery. When we are using this medicine, so these are used during the surgery. So now this is going to relax the abdominal muscles, going to relax abdominal muscles. So thereby it is not necessary to use a strong anesthesia. So that's why it is going to make very easy for the surgery to both the doctor as well as patient. So these drugs are two types: competitive agents, depolarizing agents. These are two types: competitive, depolarizing agents. The first one is competitive agents. The first one is competitive agents. So these agents act as similar to acetylcholine. Similar to acetylcholine. The first compound is tubercularine. What is the first compound? Tubercularine. Let's see the structure of tubercularine. Very complex structure. So friends, to draw the structure of tubercularine, first you take benzene. So this benzene is connected to or fused to right a 6-membered ring. At this position nitrogen is present. This nitrogen has 2 methyl groups. Yes, methyl, methyl. So now you can see how many bonds on the nitrogen. So 4 bonds. Therefore nitrogen has a positive charge. On the benzene, here we have methoxy group. Yes, and here we have OH. Yes. So now friends, this benzene is connected to oxygen, and also right exactly connected to benzene. Okay, connected to benzene. So friends, here this benzene right going to connected with right, you see the same structure, that you see the same structure. So this one the same structure, so we are taking again here in reverse. So that means first right, you take a cyclohexane ring. This cyclohexane ring is fused to right benzene. So exact structure, and you can observe here this position we have the nitrogen. This nitrogen has right 2 methyl groups. Yes, therefore nitrogen has a positive charge. And you know that right here this position we have yes methoxy group, and here this position we have an OH group. So right, so now friends, here we want to connect these two but not like this. So for that we are going to use right we are going to use right another benzene ring right connected by So another benzene. Let's take the benzene ring. Okay. So now this benzene ring, now this benzene ring here connected to this OH, and here at para position again we have the OH. So friends, this is the structure of tobacco. Yes, the structure of tobacco like this. So now friends, what is the use of tobacco and what it has? So here tobacco going to have two quaternary nitrogens. You can observe here two quaternary nitrogens. Yes, tobacco going to have two quaternary nitrogen. Here one nitrogen is bind, so one of these nitrogen binds with receptor active site and other is going to interact with the cysteine residue in the receptor. Yes, cysteine receptor residue in the receptor. This will act as a antagonist drug, antagonist agent, and blocks the neurotransmitter. So now it is going to involve in relaxation of abdominal muscles, going to relax the abdominal muscles, thereby so we can make the surgery very easy, so by decreasing the level of anesthesia. For example, if you want to do the surgery, so then so some doses of anesthesia is required, but when you use this medicine, so you can decrease the amount of anesthesia to give the patient, because anesthesia is not a good chemical. And here it is act as a neuromuscular agent, and also it has some side effects like block the autonomous nervous system. So friends, that is the tuberculin. So now the next one is a depolarizing agent. In this, the first example is succinylcholine. The example is succinylcholine. Let's see the structure of succinylcholine. So friends, let's see the structure of succinylcholine. So first, let's draw succinic acid. What is succinic acid? So succinic acid is going to have, right, yes, two carboxylic acid groups, right, two carboxylic acid groups. In between two carboxylic acid group, we have two methylene groups, or two carbons are present. That is called succinic acid. So what is our compound? Succinylcholine. So choline means it has OH, yes, CH2, CH2. So this position we have the nitrogen. So this nitrogen attached to three methyl groups. Yes, again the same one, write a nitrogen, so write attached to three methyl groups. Yes, methyl, methyl, methyl. So you observe friends, both the nitrogens have four bonds, therefore you have to write positive charge. So this is the structure of succinyl. Yes, so let's see the synthesis of succinylcholine. For that we are taking succinyl chloride. Succinyl chloride, it is going to react with 2 moles of choline. We are taking, yes, we taking the 2 moles, sorry, 2 moles of NN dimethyl ethanol amine. 2 moles of NN dimethyl ethanol amine. So what will happen friends? You know, so the acid chlorides are very reactive. So chlorine from here, hydrogen from here, chlorine from here, hydrogen from here. The loss of 2 moles of HCl going to give so this product. So you know, What is the difference between this structure and this structure? One methyl group is difference. For that, add 2 moles of methyl chloride, because here one methyl group is required, here also one methyl group is required. So the lone pair of electrons attack at this position, chloride will eliminated, forms at succinyl choline. So friends, this is the class about cholinergic receptors. Thank you.